Hello students, welcome back to my channel JP Physics. In previous lecture we have discussed about the higher and lower speed limit for a vehicle when it is moving along a banked curved road. Okay, next topic we are going to consider in this lecture, it is conical pendulum. In this we are going to derive the derivation or formula for a time period of conical pendulum. First, you have to know what is mean by pendulum. Actually, all of you know about what is pendulum. In that pendulum, one mass is there. It is attached or tied to a inextensible, frictionless, massless string, and it is moving to and fro, or it is moving or making the oscillation in a single vertical plane and supported at rigid support. Means like this. If you consider the pendulum, this pendulum is connected to the rigid support and it is oscillating like this. Means it is moving along a single vertical plane. Okay. Now, what is then conical pendulum? See, conical pendulum is a pendulum in which there is one point mass or a bob which is attached or tied to a long inextensible massless string, and it is making the revolution or it is moving along a conical surface. Means like this. It is moving along a vertical, right circular conical surface. Okay. So it is making the motion like horizontal circular motion. It is making the horizontal circle. So it will make the structure like cone, correct? It is moving like this, but it is making a cone-like structure. Therefore, it is called as conical pendulum. And we are going to derive the formula for its time period. For this, we have to consider the conical pendulum like this. See, this is a rigid support, and to this rigid support, if this is a axis of rotation, vertical axis of rotation, and pendulum is making horizontal circular motion like this. This is path of this pendulum, correct? This is axis and this is pendulum which having length L, and it is making some angle theta with the vertical axis. If I consider this rigid support as O, center of this circular path as a C, and this point mass, position of this point mass, let us consider as a A. So this is the radius of the circular path, that is, take it as a R, radius of the horizontal circular path. Now, to derive the expression for time period of conical pendulum, I have to consider FBD for this point mass. Means all the forces acting on this mass, that is point mass or that bob which having some mass m. Okay, now what is the force? One force which is acting always in downward position or downward direction, it is weight force mg. Now, if I consider this string which is inextensible long length string of length L, on that there is a, means on this point mass there is a tension acting, force acting on this bob is this tension which is present in this string. See, if to this string, if this bob is attached and it is moving like this, means there will be some tension in this string, and that tension will act in this direction, that is away from the mass. Always remember, if tension force is acting or tension is acting on any body, its direction will be away from that mass. If I consider this mass, point mass, which is present at this point A, the tension force will acting away from that mass. Means in this direction, that is tension is here. But there is no any force which can balance this weight force mg. So I have to split this tension T. Now, if I split this tension, then there will be two components. One component will be T cos theta and another component will be T sin theta. We know adjacent to the angle, the component which is adjacent to the angle, that will be t cos theta. If this angle is theta, this angle will be also theta, alternate angle, correct? So the component adjacent to this theta will be t cos of theta, t cos theta, and the perpendicular component, see this component AC, along AC, that component will be t sine of theta. This is t cos theta and this will be t sine theta. These are two perpendicular components of tension T. If you observe the figure, t cos theta balancing weight force mg, that is t cos theta will be equal to mg. So I can write t cos theta is equal to mg. Let equation number 1. Now, this t sine theta is directed towards the center of the circular path, horizontal circular path. This t sine theta is towards the center of that horizontal circular path. And we know that the force which is acting towards the center and along the radius of the path, that will be centripetal force, means this t sine theta is providing the centripetal force which is required for the horizontal circular motion of a conical pendulum. Therefore, I can equate this t sine theta to the centripetal force. Now, what will be the formula for centripetal force? mv square by r, correct? R is the radius of this circular path. So, t sine theta is equal to mv square upon r. Let this equation as 2. Now, we have to find out the time period of this conical pendulum. So, here I have to consider the relation between linear velocity and angular velocity. See, here there is an angle. Some angle is made with the vertical axis. And so I have to consider the angular velocity of that pendulum. So what will be the angular velocity? If it is omega, then relation between V and omega is nothing but V is equal to R omega. So I will put this value in this equation number 2. I will get T sine theta is equal to M R square omega square upon R. V is equal to R omega, but here there is a V square. Therefore, R square omega square upon R. One R will get cancel. So, what will be the formula? T sine theta is equal to M R omega square. Let this equation as 3. Now, if I divide this equation number 3 by equation number 1, what will I get? See, divide equation number 3 by 1. So, T sine theta upon T cos of theta is equal to M R omega square divided by mg. Get cancelled. This T get cancelled. What is the remaining part? It is sine theta upon cos theta is equal to R omega square upon g. So, I will write this here only. Sine theta upon cos theta is equal to this R upon G into omega square. See, what is this omega? What is the value of omega in terms of time period? We know that value. What is that omega? See, omega is equal to 2 pi upon T. We know all this. Omega is equal to 2 pi upon T. So, I can write this as 2 pi upon T whole square, because here omega square is there. Therefore, in place of omega, I have put that value 2 pi upon T whole square. Since angular velocity omega is nothing but angle divided by time. 2 pi is the angle of that circular path and T is the time required to complete one revolution. Therefore, 2 pi by T is nothing but the angular velocity. So, here I can put in place of omega, that is 2 pi upon T whole square. Now, if you observe this figure, AC distance is nothing but the r, that is radius of the circular path. If I take the right angle triangle OCA, by applying trigonometry, sin theta will be, sin theta is equal to, what will be sin theta? Opposite upon hypotenuse. Here opposite side to this theta, it is AC and hypotenuse is OA. Therefore AC upon OA. What is AC? AC is nothing but R, and what is OA? That is the length of the pendulum, and it will be L. Therefore value of R will be L sine of theta, correct? See, R is equal to L sine of theta. Therefore value of R we will put in this equation. Then what I will get? See here, sin theta upon cos theta is equal to, in place of R I will put the value L sin theta, that will give us L sine of theta upon G into 2 pi upon T whole square. Sin theta will get cancelled. So 1 upon cos theta is equal to L by G 2 pi whole square upon T square, right? 2 pi whole square upon T square. Now I will take this T square towards the left side. So what will happen? See, T square is equal to L, this cos theta will get multiply here. Therefore L cos of theta upon G into 2 pi whole square. Correct? Now if I take square root of both the sides, what will happen? T is equal to, this 2 pi I will write towards this side, 2 pi, and in square root I have to write L cos theta upon G. That is, time period of conical pendulum will be having formula 2 pi under root L cos theta upon G. This is nothing but the time period of conical pendulum, right? Again, if you see this formula, this 2 pi, it is constant. Length of the pendulum, it is also constant. And G, it is also constant, because we are making the horizontal circular motion, means this plane is same, this height or this level is same. Therefore G is not going to be changed, means 2 pi L and G are constant quantities. Therefore time period will depend upon only theta, that is angle made by this pendulum with the vertical axis. Means on which factor this time period of conical pendulum depends? Only theta, only angle made by the pendulum with the vertical axis. Also you can conclude one thing. See, there is a term cos theta. If I took this pendulum in this position, means not like this, correct? If I take like this, it is not possible that it will make the oscillations. Why? See, if the position of this pendulum will be like this, vertical axis is here, then angle will be 90 degree. And if I put theta as a 90 degree, cos theta is nothing but, cos 90 is nothing but 0. Therefore time period will be 0. It is not possible. So theta is equal to 90. This condition is not possible. In another way also you can understand. See, here we have taken the component as a t sin theta and t cos theta. When I consider this horizontal position, in this case vertical component will get finished, means vertical component will be equal to 0, and there will be no any force to balance this weight force mg. Means theta is equal to 90 degree, means the horizontal position of the pendulum, it is not possible. You understood this derivation? Simply you have to draw the FBD for point mass which is situated at one end of this pendulum. If you draw that FBD, balance the forces, put the values required, that is V is equal to R omega, and then omega is equal to 2 pi by T. You will get the derivation for time period of conical pendulum. You understood this derivation? You like this video? If you like this video, please share, like and subscribe my channel, and also press the bell icon because you will get the notification of next lectures, because in that lectures I am going to give the information how you can prepare the board exam, means how you can prepare for the physics paper to write in board exam. So press the bell icon so you will get the notification of that lecture. Okay, thank you.